All right, lesson 7.4, power series, geometric power series, integration and differentiation of power series. A series with variable terms like this is called a power series. You can see the power means the exponent, and it's increasing as you go along. Now, this series is a geometric power series if it converges what must be true about the variable x. And so what you're multiplying by every time is x. That's what the common ratio is. So what do you multiply? You're multiplying by x. And so what must be true is that answer for x must be between -1 and +1. If that's the case, the common ratio is that way. Another way to write it is that the absolute value of x must be less than 1. If that's the case, it converges. And what it converges to is the formula. And the formula is the first term over 1 minus the common ratio. So in this case, it's 1 over 1 minus x. So again, this is the formula that we're using for an infinite geometric series. In this case, the common ratio is x. This means that for x values for this function can be written as that. So the answer to this is just 1 over 1 minus x. So find a power series for each of the following functions. Show the 4 terms and the general term. And then also give the series using sigma notation and give the interval of convergence. So in number 1, the first term is 1. I'm going to rewrite this so it's 1 minus, because the form is 1 subtract and for these to match, then what's inside must be -x, so they're the same. But that means my common ratio is -x. So to write this, it would be the first term and then -x to the n minus 1. You could also start it at 0 and it would just be n instead of n minus 1. And then what's the answer to that is this. It's 1 over 1 subtract, which is 1 plus x, subtract -x. There it is. So these are now equal to each other. If I write down the first terms, the first term would be 1/2. Sorry. The first term would be using, it'd be 1. And then if we have -x to the n minus 1, if I plug in 1 or 2 or 3, it's going to alternate whether it's negative or positive. So it starts with 1, then the next one's going to be negative, because an odd exponent would make it negative. Then the next one will be positive, then the next one will be negative, and so on as it keeps going. So those are the 4 terms. Now, what's the interval of convergence? You take the common ratio, which is -x, and it's less than 1. Another way to write that, the absolute value of -x is just x. And you have it. And that's called the interval of convergence. All right, so step 1, I'm going to write this as 1 subtract, and then you can see it. So 2x is going to be the common ratio. So the first term is 3, and the common ratio is 2x. So if I write this, I could do it with, here, this is what it will look like for 0. So we have 3, and then 2x is the common ratio to the exponent n. And then the first 4 terms would be plug in 0, plug in 1, and you get 6x. Plug in 2, and when you square it, it'd be 4 times 3, so it'd be 12x squared. Plug in 4, that'd be 16 times 3, 48x cubed, and so on. Oh, did I do that right? So if I plug in 4, 2 to the 4 is 16. I started at 0. Silly. So I started with 0. Then when I plug in 1, then I plug in 2, I'm plugging in 3. So 2 cubed is 8, and 8 times 3 is 24. X cubed, and so on. Take that 2x, and that's going to be greater than and less than negative 1 to 1. Divide by 2, and that gives you the interval of convergence. Number 3. So we need to write this as 1 subtract for it to work. So this is going to be 1 take away 3x. That means when I expand this, it's just equal to 3x. So 1 subtract 1 is 0. And when you subtract negative 3x, it's positive. So I need to write it in the right form. When I write the sigma notation, we start with the first term, and then it's 1 minus 3x to the exponent n. That's the geometric power series. If I plug in 0, the answer is 1. If I plug in 1, the answer is 1 minus 3x. If I plug in 2, I'm just going to write 1 minus 3x squared, and so on. So there it is. There it is. Take the common ratio, 1 minus 3x. That's going to be greater than negative 1 and less than positive 1, and then solve it. So subtract 1 to both sides. Divide by negative 3. Now when you divide by negative, the arrows are going to change direction. So when you divide by negative 3, this should be 2 over 3. So a negative divided by negative is positive, and then 0 divided by negative 3 is 0. You could also write it like this, and that would be the same answer. That's called the interval of convergence. This thing converges when x is between 0 and 2/3. All right, number 4. Use the power series from example number 1 to make a new power series for x squared. So if I look here from number 1, I'm just copying down what is above. So that's what it looked like. I'm just copying this above here, down here. So x squared means I just plug in x squared where there's an x. So this would be 1 over x squared. This is a minus. And then plug in x squared for x. Just plug in. And you can simplify the exponents if you want to the 4, to the 6, and so on. From example number 2, use the square root of x. So in example number 2, where there's an x, I'm going to put in the square root of x. So it's 3 plus 6, but instead of x, it's the square root of x. And then 12, and then it's the square root of x squared. And then it's 24, and the square root of x cubed, and so on. Following that pattern, just taking out the x and putting in the square root of x. All right, turn the page. Use the power series 1 over 1 minus x on the previous page to do the derivative. So 1 over 1 minus x was this. X plus x squared plus, and so on. The derivative of that would just be the derivative of each term. So the derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x. The derivative of x cubed would be 3x squared, and so on. So just taking the derivative of each one. Number 7. Here we have a power series. If you take the derivative of each one, you just take the derivative of each term. So the derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x, and then the 2 factorial is just 2 on the bottom. The derivative of x cubed is 3x squared, and 3 factorial is 6. The derivative is 4x cubed, and 4 factorial is 24. And if you simplify it, can you identify what j at x equals? Well, 0 plus anything. We'll start here. Notice it's 1. 2 divided by 2 is x. 3 goes into 6 twice. 4 goes into 24 6 times. 3 factorial is 6. These match exactly. This and this are exactly the same when you simplify it. And if you have a function and you take its derivative and it stays the same, then g at x must equal e to the x, because the derivative of e to the x stays e to the x. The derivative of this power series stayed the same when you simplify it, so that's what it's equal to. Number 8. Since 1 over 1 plus t is this alternating power series, integrate from 0 to x. So the integration of a fraction is a logarithm. And when I integrate each one here, just go one at a time and integrate what you see. So the integration of 1 is t, and this would be t squared over 2. This would be t cubed over 3, t to the 4 over 4, and so on. On the left side, plug in x, and you get ln 1 plus x. Subtract, if you plug in 0, ln 1 is 0, so I don't need to go subtract 0. On the right side, plug in x. When I plug in 0, subtract, it just gives you 0, so I don't need to subtract 0. And this is true when the interval of convergence is between -1 and +1. Use the result from example 8 to write a power series for the function ln x. So ln x, using this above, is ln 1 plus x, take away 1. Come on in. And then hey, come on in. Here, put it right here. Thank you.
Thank you.
No, thank you. I'm back. I'm not going to do another video. We're all good here. All right. So do notice that this is in the form that it needs to be in. And they're the same, right? 1 plus x, take away 1 is just x. But it's now in this form where I can take out the x and put in x take away 1 in its place. So just do a substitution and put in x minus 1. And you did it. So now write a series for x squared ln x. So if I go x squared ln x, I can take what I did up here and just multiply everything times x squared. And you did it. That's it. All right. Mr. G Math over and out. Even with a little break, we got to the end of this. All right, let's do the assignment together.